bottom here is going to be 34 squared, which I'm actually going to leave as 34 squared right now, and here's why. Because 34 squared is like 34 times 34, right? So I'm just going to say, well, then that one cancels out with that one. That way I don't have to like multiply it out and then simplify it later. And I'm going to call this 1 over here 34 over 34. Does everybody understand why I'm doing that? Okay, now what should I do? Right, so now I've got sine squared theta equals 34 minus 9, which is 25 over 34. Square root. Sine of theta equals 5 over the square root of 34, which we'll have to rationalize. Positive or negative sign in quadrant 2?
Positive.
Because?
It's the y coordinate.
Right, and the y coordinate is positive in quadrant 2. Okay, how are we feeling about this so far? Okay. Now we're going to do, so this section is basically built up, separated into 3 things. We've already done one of them, okay? One of them is this, and we had kind of done some of that stuff last time, right? Your homework is going to have only one of these problems in it, but it's going to make you find all 5, but that's all. There won't be multiple ones, okay? And let's be honest, once you have sine, how do you get cosecant? Flip it. Once you have secant, how do you get cosine? Flip it, right? We found cosine right there. We found 3 of them just together. So a lot of these will be pretty easy and pretty fast. The second part is filling out another one of these. So take out the back of your unit circle, and we're going to fill out these ones, which I'm going to call the opposite angle identities.
How many boxes are we filling in?
1. There are going to be 6 things written in this little box, but they're going to be pretty easy, pretty small. I'm just trying to give you an idea of how we're going to fill it. Okay. It's basically sine, cosine, tangent, cosecant, secant, and cotangent, just with negative theta inside instead. Okay. So, need some more time? You good? Okay. All right. So, let's say we had tell me right now, just by looking at my unit circle, I mean, you can look at yours too. What is the sine of 30 degrees? Everybody getting pretty comfortable with that at this point? Do you guys remember how cute it was when we were doing a benchmark and I was like, what's the sine of 30 degrees? And you're like, how would we know? And I was like, it's y. And you're like, where's y? And I'm like, it's the y value. We're all right, guys. Everybody's okay. Do you remember when I brought up SOHCAHTOA for the first time? And you're like, SOHCAHTOA? These ones are impossible. And I was like, triangle problems? And you guys are like, yeah? How would you know? And I was like, we'll figure it out. Look how far you've come, okay? Look, you were just a few months ago. I was like, find the XY intercept. It was impossible. It's not true, but 4 years ago it was true. So, this is 1/2, right? What is the sine of negative 30 degrees? Negative 1/2, because all we're doing is just going from here to here, right? Does that work for anything with sine? Let's pick a different angle. Let's pick 120 degrees. 120 degrees, what's the sine of 120 degrees? Square root of 3/2. What is the sine of negative 120 degrees? Okay, so this always works. The sine of negative theta is negative sine theta. So that means whatever the sine of the top one is, if you just put a negative sign in front of it, that's it. Okay, let's try cosine. Cosine of 30 degrees? Square root of 3/2. Cosine of negative 30 degrees? So does it change the sign? No, in fact, it turns out to be exactly the same. Let's make sure it's the same everywhere. Let's try the cosine of 135. And negative 135? They're the same, right? So I'm going to write that the cosine of negative the angle is the same thing as cosine of the original angle. They're equal. Okay, tangent's a little harder. Let's try tangent. I'm not going to ask you, well, yeah, let's do it this way. What's the tangent of 45 degrees? 1. You take y and you divide by x. Is everybody with me right now? Even if you don't have tangent memorized by now, you know where on your unit circle to look to find out that you do y divided by x, right? So 45 is 1. How about negative 45? Negative 1. You see how if we go across, one of them goes negative, which means that the ratio turns negative? So what should I write for this on my opposite angle identity sheet? Mm-hmm. And I know that this formula looks confusing. So this is what it means. If you take the sine of negative 30, that's the same thing as putting a negative 1 in front of the sine of positive 30. So basically across the line, they just become negative of each other. They become opposites. Cosine, if you go across the x-axis to either side of the y, they're actually the same. So cosine of negative 30 is the same thing as cosine of 30. They're equal to each other. This one, tangent of negative 30, is equal to the negative of tangent of 30. So they're the same, but there's a negative sign. Okay, now can anybody tell me what these might be? Cosecant is just 1 over x, right? Or 1 over y. So what do you think the rule is for this one? Which one of these was y? Sine. So if we're doing the same input, let's make it easy. Okay, so what is the cosecant of 30? Flip that y upside down. 2. What's the sine of negative, or what's the cosecant of negative 30? Negative 2. Do you see how these two rules are matching each other?